Hey there, it's Max. This is the Bucket Shop Challenge made by Josh from the 6th annual Spokane Cyber Cup. This is actually quite my wheelhouse. I really like heap exploitation, and I think this is a really good introductory heap exploitation challenge. It teaches the concept of a use after free, and that's pretty cool. So let's get into it. Bucket Shop. Congrats! You're the proud owner of a bucket shop. You have only a single bucket that you can use at this time, sadly. The old owner left a secret laying around though. Can you find it? To get the flag, exploit a use after free vulnerability to get your bucket loaded as the secret. To connect to the challenge, SSH to this and with these credentials. Hint, use the gef heap commands. So gef, or Jeff, I'm not sure how to say it, is a GDB extension on top that makes heap exploitation, binary exploitation, and various other things easier. So we can start by just looking at the source code for the challenge. Or we can just go here and look at the options. There are 4 options: buy bucket, return bucket, print bucket, and hide the shop secrets. The first option allows you to allocate a chunk of a size that you choose, and that is your bucket. The next option, which is 2, allows you to return the bucket, give the bucket back, which is just going to free it. That's it. Number 3 allows us to view the bucket. So it just lets us see the string within the bucket index. And of course, it has a bounds check on it as well, just like this one does. And then the 4th one is it's going to read the contents of the flag into this mallet chunk size 32, and then that's it. So at first glance, we can't just read this. The top secret is not linked to any of the bucket information. And this is where some heap tomfoolery needs to come into play. So what actually is the heap allocator? The heap allows you to reuse memory. And when you call malloc or memory allocate, it gives you memory to use. And when you call free, like when we have here, it allows the computer to reuse that same memory again. And this is the whole point. If you just had this big memory index and you used it and you used it and you used it, eventually you run out. But if you say, hey, I'm done with this memory, something else can use this, then the other piece of memory other locations can use that. Now, this creates a fairly unique vulnerability class though. This is where the concept of a use after free comes in. So if you free something and then you try to use it afterwards, then you have some major issues. Although you should be done with it, saying, hey, I freed this, I don't want this anymore, you still may be able to access it if you have a pointer to it. And that's exactly what we have here. So in the case of freeing the bucket, we're actually just calling free. We're not removing the pointer. The proper way to do this would be to do buckets of bucket index equals null. And that way, it would try to do like a null dereference and it would just crash instead of outputting the flag like we'll see in a moment. So because of this, we have a pointer to this memory still, even though we're not doing anything, even though we shouldn't have access to it anymore. So I believe you only get 1 bucket actually. So there's a bucket limit. Yeah, you only get 1 bucket, which is kind of funny. So at first, we can call buy bucket, and we'll do a size of 4. Then we can do print bucket, and this won't show us anything because we're not actually there's no text or anything we're putting in there. We can return the bucket, and then we can hide the shop contents if you wanted. Now, when you allocate these buckets, notice how it's giving you these pointers here. This is nice. And in this case, the pointers are different. And there's a reason for this. So this goes into why we need gef to solve this challenge. If on the box, I have gef loaded onto it. So if you do gdb bucket, then it will load get for us. And if we type in heap, it'll give us, we need to run first. And if we type in heap, if we cancel it and then run heap, this will give us some nice debugging information here. So heap chunks, heap bins, these are all the various commands we can run. Now the only ones really need to know about are chunks and bins. In glibc malloc, which is what we're using here, a chunk is a particular allocation that is given back to us. The bins are the holding areas for chunks that are no longer in use. If we type the bins command, we haven't freed anything, and so we'd expect for this to be empty, and that's true. All T caches are empty, fast bins are empty, all these bins are completely empty. If we just type in heap chunks, of course the program is going to use it for various things. We can see that it has sidesec shop, which is a string that we loaded. So the heap is not just used for us calling malloc, it's used from other parts of the program calling malloc as well. But using the chunks command and the bins command, we can start to get a feel for how stuff works. So now if we continue and we do by bucket, and we say size 4, then we do this cancel, and if we do heap chunks, well, I'll have a new allocation, and it's right here. So one thing that is kind of weird about malloc is the sizes. If we look at what we're doing here, we're calling malloc directly on the size value that we control, and there's no size of 4. This is because all of the chunks have to be a minimum of hex 20 in size, and they have to be in groups of 16 bytes on 64-bit systems. An additional constraint is that you need at least 8 bytes whenever for the metadata of the chunk. So all this to say, there are some complications that isn't particularly obvious. But one thing that should be noted, though, is we need the chunks to be the same size between these two. So the goal is to get the top secret chunk that we have right here that has the flag to be in the same location as our free bucket. And the size here is 32. So without knowing all of the shenanigans and all the inner workings of the heap, we can see we have a size of 32 here, and which means we probably want a size 32 here as well. So I'm going to open up GDB with bucket again. And of course, we can actually open the flag here, so GDB becomes a little bit more annoying to use, but you have to trust me on that. So we're going to do by bucket, and I'm going to do size 32. We're going to do return bucket, and then we're going to do the bins command, heap bins. And this time, you'll notice that there is a chunk in the Tcache bins. It has a size of hex 30. Now, why is it hex 30? We gave it a value of 32. It has to expand up. So even though it should only be hex 20, we need that extra buffer room for the heap metadata, so it always adds that hex 10 there. And now, if we do the next command of the hide shop secrets, when it tries to read into it, it will crash because there's not actual allocation stuff there in GDB. But if I'm curious to see if we do heap bins, it no longer has that chunk in there. There's some weirdness. The program's crashing is what's happening here. But the Tcache bin that we had here is no longer here. So we can't read the flag because in GDB, because otherwise you just read it from memory. Set your ID doesn't work on GDB enabled binaries. So you have to trust me on this. But I'm going to do by bucket, return bucket, and then I'm going to do hide shop details. So notice that this chunk will say AC0 is now going to be the same exact thing as AC0, which tells us that we reuse that allocation. Remember, there's a use after free on this third option here. So if you do 3 and read the bucket, we now get the flag out of it. Debugging GDB is a little bit annoying, but I hope that the core concept of the use after free makes sense. We allocated memory, we freed it, but we still have access to it, and we're then going to allocate our flag onto that, and because we have a use after free to that chunk, we can still access it. So that's the bucket shop challenge. Hope that was fun. Thanks, everyone.